Hi everyone, and welcome to Foundations of Java. Today is our last class, so you guys better be on your A game. We're starting off with a review, and last week we did formatted printing and while loops and combining the two. So now if we take a look at this piece of code, right, I want you to type in the chat what it will print. So using our little boxes system, we have a space and then 9, space and then dogs. So if we take a closer look at our problem, we see that we want to print out %2d. So remember, 2 boxes, and this d refers to dogs. So yes, 9. And then afterwards, you would just print out the space, the dogs, and then it'll be entered on a new line. And then the variable dogs will be subtracted by 3, giving us 6, 3, and 0. And because I said it was greater than or equal to 0, then we will also have the 0 dogs. Otherwise, it would just be greater than, then we wouldn't have this last line. So now let's move on to our first topic of the day. We're going to be talking about string equality. So we're testing to see if one string is the same as another. So remember when we're checking equality, when we have like variables such as ints and doubles, we would just use the equals equals. And it just checks as the value is the same. However, would you think that works for strings? Like, let's say we have an S and that just is a string. And maybe we do these quotation marks to say, is it equal? Because strings have quotation marks. Now, clearly the answer is no, but can you guys think of any other way you might be able to implement string equality? So this equals equals doesn't work for strings. If you tried it out in a piece of code, it will give you an error. It just won't work. Now we ask the question, why won't it work? So the way to do it is, it's because equals equals can only be used for something called primitive values, which are ints and doubles. Now, primitive values, of course, are values that are primitive, and we'll talk about this a bit later in the class, but for now, just think of them as simple values. So, and because equals equals only compares whatever is stored in the variable itself. And strings, however, are not primitive values. So we can't use something used only for primitive values for something that is not a primitive. Instead, a string is something called an object, which is a bit more complex than primitive, and it has more functions. If we use equals equals for comparing objects, we only compare their references, not the actual content of the objects. Now, this might be a bit confusing at this point, but it will be elaborated on further on. But here's the answer to the question before. To compare string equality, object equality, we used dot equals and the parentheses. So let's take a look at that. So let's declare a variable, a string variable. So remember that string is capital S. We'll just do this example as always. Don't forget your quotations, and just say letter A. So let's just see, let's write an if statement. So if example, and instead of equals equals, dot equals, and we need these quotation marks as well, equals A, braces, and then we'll just print out So let's run this. So that's how you do it. Now, if you want to test if something is not equals to this, like if you want to, because if you want to do it for your primitives, remember you would just do exclamation point and equals instead of equals equals. Now, the concept is pretty similar. Instead, if we want to check if it's not equals, first we'll just type out this at first, and we'll just say B. Instead of where we want to put our exclamation point is right at the beginning, before the variable. And then in this case, we would print out so there, we would have they're equal and they're not equal. So that's how we would do string equality. Simple as that. Okay, so this just basically tells us what we did so far, what I demonstrated in the Replit. So here, remember that we always need these quotation marks if we're gonna be checking if it's equal. And the exclamation point is before the variable. So now let's talk about data types. Remember how I mentioned primitives and objects previously? Well, here's where we're gonna talk about them. So remember our data types, which we talked about on the first class of this course. We had our ints, we had our doubles, our strings, but we can separate those data types into two groups. We can separate them into primitives and objects. So primitives are just one piece of data. These include ints, doubles, floats, boolean, and char. And these store the value of the data. So remember when you're declaring a variable, you have this int that you declared and you're making it equal to 10. Now, this variable is directly storing the data of this 10. So when you call on this variable, it will give you 10 because it's storing that data. However, for an object, it represents complex data and behaviors. Some examples of these are string and scanner. And it's pretty fun to note that primitives, well, for the data types, they're all lowercase, but for the objects, the first letter is capitalized. So that's one way you can distinguish between them. Now, objects, they store the reference to the data, not the actual value of the data. They store a reference. So let's say you're making a string and the string is equal to the word hello. But instead of directly storing hello, hello is stored someplace else, and you're just referring to a reference of the data. You're not actually referring to the real hello. It's just a copy of hello, and you're just referencing it. So let's take a look at more primitive data types. You guys are familiar with ints, doubles, but we also have floats, which is just a decimal value, but smaller. We have booleans, which are used for true or false. And remember before that a value can only be either true or either false. It can't be both, and it can't be neither. And there's also something new we haven't learned before called a char. Now a char is just a single character. So it can just store one character. So let's talk more about the reference to data. I mentioned it before, but so this data is kept elsewhere, and the reference refers to the location in memory. And objects can have large and complex data and behaviors, so it's stored somewhere else with more space. Okay, so let's quickly test out our understanding of strings and like string equality. So we'll do a quick project. So our goal is to write a program that asks the user what their favorite sport is. If the user inputs whatever, you can check to see whichever sport's equal to, you want to print out that's cool. Otherwise, you would print out, okay, whatever, or anything else. So we have to use string equality, use user input, and if else statements. So I'll give you guys some time to do this one. Okay, this one wasn't too bad. So let's take a look at the answer to this one. This is what I have. So here I imported my scanner. And we recently learned that a scanner is a type of object. But nonetheless, the way we use it is still the same. So I print out the statement, what is your favorite sport, and declared a variable asking the user to input a string. Then over here, I did my sport.equals, and for me, I said figure skating, and then print out that school. And I also used else because I did not want to retype out else if and put an exclamation point in front of this, so I just did else. And I just did print it out, okay, whatever. Close my input, and let's run this. So what is your favorite sport? Let's test it out and say my favorite sport instead was soccer. Then it will say, okay, whatever, which runs the second part. And then let's do it again. And this time I said figure skating, then it'll say that's cool. So yeah, our string equality works in this case. Okay, so now that we have that, we're going to move on to our rolling dice project. So our goal is to write a program that simulates the rolling of a fair six-sided dice 500 times and see what % of the time you roll each number. Now, this does seem a bit complicated, and there is one part of this that I haven't really explained yet, but I will. It's down here. We want to use while loops, which you guys are set on, formatted printing. You guys are also set on, but we also want to use math.random. Now, I don't think I've explained math.random before. I have explained math.pi, which you guys have used in a previous project. But math.random gives you basically a random number. So if we print something out like this, it should look somewhat similar to that. And we want to format print it. So maybe we want it to have 1 decimal place, 2, or 0. But before we do that, let's quickly explain math.random. So what math.random does is it generates a number that, is a double in the range between 0 and 1. And notice how I formatted it in like the square bracket, 0, comma, and then instead of another square bracket, I did the parentheses. Now, if you guys are familiar with a bit higher level math, you'll know that what this means is that the square bracket means inclusive and the parentheses means exclusive. So this basically would give me any number like 0.112, 0.99, any decimal number. It can even give me 0, but it cannot give me 1. It can go as close to 1 as it can, like with as many like 9s as you want, but it cannot reach 1. But what happens when if we want to simulate this six-sided dice, right? We can't have a bunch of decimal numbers on our dice, right? Our dice only has 1, 2, 3, 4, 5, and 6, right? So what we would do is we would do some casting, as we've done before, and we'll turn it into an int. So instead, if we just had something like, let's make a variable int, we'll call this dice roll, and then we cast as an int because we want an int. And if we did that, math.random with the parentheses, this all the time would just give us 0. But we don't want 0 all the time. We want numbers from the range of 1 to 6. So anybody have any suggestions as how we would get the range from 1 to 6? Or maybe 1 to 6 from 0, 1? Okay, so there was a hint up here that I didn't really mention. And it says multiplying by 10 scales this decimal to the range of 0 to 10. So if I just multiplied this by 6, from 0 to 1, it would go from, by this, it was 0 to 6, 0 to 5. So if we add 1, instead, it would just go from 1 to 6, which is exactly what we want. So that's a fun way we can manipulate math.random. So let me just add this to the notes up here. So adding a number will add that number to the range. So this would give us numbers from 1 to 6. And once we have this, we're going to want to count the number of times we're going to roll this dice, right? The number of times we're going to run math.random. So we're just going to make a variable that counts this number of times. I'll just call it counter, and we'll start off from 0. So then we're going to do our while loop, while counter is greater than or equal to 500. And this is where I'm going to leave you guys to write the code. Remember, what we want to do every time is we want to rerun dice roll so that it gives us a new number. And then once you have all 500 of your numbers, you're going to want to see how many times you roll each number. So I would also suggest having a counter for like every time it rolls a 1 or every time it's a 2. And because we want to check for equality, this time we use equals equals because it's not a string. Okay, guys, so progress on this project is looking good. Some of you have finished. So I'm just going to show you guys the solution to mine. So here's our counter, and in between the while loop and our counter, I put a bunch of different counters for the number of times it's going to count the occurrence of each number. So 1, 2, 3, 4, 5, and 6. And I admit this project was kind of an oversight because I had to type out or copy and paste every single one of these, which could have been fixed if I just told you to count how many times and print out only 1 or 2 or 3 and not all 6 of them. But it's pretty much the same thing. So I set each of these counters at 0. So here we have our dice roll, which is different every time. And I said, if this dice roll is the value of is equal to 1, we're going to increment our 1 counter 1 up, just to say, yes, this has been counted once. And since it's an if statement, it'll just skip the rest and none of the others will get incremented. And then at the end, I put for my this counter for the 500 times we're going to run this. Just to increment it, I changed it to less than, just for 500. And then down here is where I had all of my system.out.prints. Remember, it's printf for formatting. And I decided to use only 1 decimal place. So let's see, this should work. So yeah, I had 1 rows to roll this percent of the time, this. And you notice that I did say it was a fair 6-sided dice in the beginning, but you notice how these numbers, they should be all the same, but they aren't. Well, I mean, it's statistics, but I only rolled this dice 500 times. The more I roll this dice, the more these numbers are going to come in on like one number, which is 100 divided by 6. But yeah, that's the project. So let's finish off class, shall we? So thank you guys for making it to the end. And this time it is the end of our 6-week course. So subscribe to our socials and visit our website if you want to sign up for any more courses just like these taught by other volunteers. And here's my email. You can email me for the slides or for the replets. And that's all, guys. Okay. Have fun, guys. It's been
Bye,
fun.
everyone.
Bye.